Welcome, focused learners, to the dojo. Today, we are stepping right onto the mat for an absolute masterclass in Cambridge computer science exam strategy. Whether you're currently tackling syllabus 0478, diving into 0417, looking at 2210, or even gearing up for the advanced 9618, the core philosophy we're teaching today remains exactly the same. You must flow like water. You have to adapt your style to absolutely any question the examiner throws at you. Now, let's think about two archetypal students we see all the time in these exams. First, there's Alex. Alex is brilliant, no doubt about it, but Alex overloads every single exam answer with raw computer science facts, basically throwing everything at the wall with zero analysis. Then, on the other side of the room, we have Sam. Sam knows the material, but Sam rushes. Sam completely misses the specific command word requirements and leaves precious easy marks sitting right there on the table. Our mission in this strategy session is to completely transform those flawed answers. We're going to build a comprehensive, foolproof strategy for mastering database concepts so you never, ever fall into the traps that snare Alex and Sam.
Okay, let's dive into this. I want you to really ask yourself right now, could you build a flawless database from scratch in under 10 minutes? Because honestly, that is the ultimate exam obstacle course. The Cambridge examiner isn't just testing your memory here. They are testing your precision under immense ticking clock time pressure. When they ask you to define a structure or build a query, they are looking for surgical accuracy. Alex would spend 15 minutes writing a literal novel about databases, talk about server arrays, and completely run out of time. Sam would just write 3 words, skip the technical depth, and get a 0. We are going to find the perfect middle path today, the true dojo master's approach to the computer science exam. We're going to decode the specific assessment objectives that the Cambridge board uses to grade your papers, and we're going to use the Peel framework to make sure every sentence you write earns a mark.
To get there, we have a very clear 5-step syllabus to conquer today. We're going to start with the building blocks, then picking data types, move into the primary key rule, tackle validation versus verification, and finally, take on the final boss, mastering SQL queries.
Every grand strategy starts with understanding the absolute basic terminology. Let's look at Section 1, Building Blocks, the foundation of data. Let's start with the macro-level structure, the table. Now, what's really interesting about this is how elegantly simple the actual definition is. It's just a collection of related data organized into rows and columns. When Sam sees the command word, explain the meaning of a table, he might just quickly scribble down where data goes and sprint to the next question. 0 marks. Alex might write a massive paragraph about how relational databases run on SQL servers and use graphical user interfaces. Again, 0 marks for all that extra fluff, and he literally just wasted 3 minutes of exam time. The examiner's mark scheme is incredibly rigid here, folks. They are looking for specific keywords, related data, rows, and columns. A table is the main arena where our data lives. If you're asked to define it, you don't tell a story. You get straight to the point, you deliver the precise vocabulary, and you bank the points.
Let's zoom in a bit closer to our second building block, the record. A record is a complete set of information about a single entity, represented as a row. Think of this as one horizontal slice of that overarching table. For instance, if we have a school database, one record represents one specific teacher's entire profile, their name, their subject, their classroom, all in one horizontal line. If the exam asks you to distinguish between a table and a record, your strategy is to immediately highlight this relationship. The table is the whole collection, the record is the individual entity within it. In our dojo, we call this the macro to micro transition. You must demonstrate to the examiner that you understand the hierarchical structure of a database system, from the big picture right down to the specific entry.
And this brilliantly illustrates our final foundational building block, the field, a single piece of data or attribute within a record represented as a column. If the record is the teacher, the field is just their first name or just their subject. It is the absolute micro level. By clearly defining table, record, and field, you've just secured the foundational marks. We are locking in those points. Notice how we aren't just reciting facts blindly like Alex, we are demonstrating the exact architectural layout of a database system precisely as Cambridge defines it. You need to visualize the grid. The table is the whole grid. The record goes across, the field goes down.
Now we shift to Section 2, and we are entering a real-world exam scenario taken straight from the source material, the ice cream challenge. Cambridge loves to give you contextual scenarios.
Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's break down the 4 basic data types required by the 0478 syllabus. I want you to mentally map these to everyday items as you look at this table. First, we have text, also known as alphanumeric. This holds letters, numbers, and symbols. Examples include chalk ice or raspberry. Second, we have integer, which is a whole number used for counting, like 34 for the number in stock. Third is Boolean, which represents data with only two possible states, like true or false, yes or no. Finally, currency or real numbers, which handle decimal values, like $2.50 for a price. Memorize this toolkit. You literally cannot build a database without knowing exactly which tool to pull from your belt for a specific job.
Now let's apply this to the ice cream database requirements. We need to store details like type, such as chalk ice or lolly, flavor, size, number in stock, and reorder level. The command words here are absolutely vital. The prompt says, write down names for the 5 fields. For each field, state with a reason the data type and give a sample. Remember our friend Sam? He lost massive marks here because he rushed, just wrote text, and moved on. He completely missed the instruction to state with a reason. He ignored the command word. We are going to decode this command word right now and apply our ultimate strategy to make sure that never happens to you.
So, the crucial point is that we must follow a specific 3-step formula to successfully extract maximum points for data type exam questions. This is where we applied the PEAL framework: point, evidence, explanation, link. Step 1. Read the requirement carefully from the context. For example, the sizes are small, medium, and large. That's your evidence. Step 2. Pick the data type. Here, it must be text or alphanumeric. That's your point. Step 3. Justify your choice. Why? Because the data consists of a string of alphabetical characters. That's your explanation. By utilizing this 3-step justification process, you literally force the examiner to give you full marks. You are providing the point, the evidence straight from their prompt, and the logical explanation. That's what happens when you follow a structured approach instead of just winging it.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Moving swiftly into our third act, the primary key rule.
Here is your gold standard, perfectly structured definition. A primary key is a field that uniquely identifies every single record in a database table. I am heavily emphasizing the word uniquely, because if you leave that single word out, you lose the mark. Period. It is the linchpin of the whole system. A primary key ensures that no two records can ever be confused with one another, even if every other single piece of data in their row is completely identical. Without a primary key, a database descends into complete chaos, and your exam score will definitely follow suit.
Now, let's put this into practice with our ice cream database. I am challenging you directly right now. Look at the data fields we established: type, flavor, size, number in stock, reorder level. Why can't we use flavor or type as a primary key? If Alex were answering this, he might say, because flavor is a text field. Well, that's a true statement, but it completely fails to answer the question, and it shows a severe lack of analytical depth. We need to identify the exact flaw in the logic of using existing descriptive fields.
The flawless answer is this, because flavors repeat. You can easily have multiple ice creams that are raspberry flavor. Maybe one is a lolly and one is a cone. Because the data in the flavor field is not guaranteed to be unique for every single record, it completely violates the fundamental rule of the primary key. So the crucial point is that since multiple ice creams share attributes, we must invent a unique ID. We create a surrogate key, a brand new field named Ice Cream ID, and we assign it a data type of text or integer, like IC001, IC002. This proves to the examiner that you don't just memorize textbook definitions, you actually understand how to engineer solutions when the provided data isn't sufficient. You are thinking like a database architect.
Let's transition to Section 4, Validation versus Verification, the ultimate trap. This section addresses one of the absolute most common pitfalls for students. This is where we begin our interactive workshop phase. I need your total focus here.
Okay, challenge 1. Let's do a quick data scan on the teacher database structure. Imagine a 60-second timer on your screen right now. Scan this. We have fields for name, title, license like L1234, gender, subject, and class. I want you to extract the core trend here. Notice the strict formatting of the license field. It's a letter followed by numbers. Notice the gender is restricted to just a single character, MRF.
Understanding the constraints of this data is the absolute prerequisite to figuring out how to check it for errors. You have to analyze the constraints before you can protect the database.
Now for challenge 2, find the flaw. Students constantly mix these two concepts up and it bleeds marks. Let's make it impossible to forget. Validation is automated checking by the computer to ensure data is sensible, reasonable, and follows the defined rules. For example, a range check or a presence check, or in the case of our teacher database, a strict rule that gender can only be M or F. It doesn't mean the data is factually right, just that it's allowed by the rules. Verification, on the other hand, is checking if data was entered accurately from the original source document. This is usually done by human intervention, like double-entry verification, where two people type in the same password to make sure they match, or a visual check against a paper form. Validation asks, does this follow the rules? Verification asks, does this match the original?
Challenge 3. We are moving right into our speed writing challenge. Imagine a 30-second timer counting down. Based on the teacher database we just looked at, which exact field would you choose to verify, and which would you validate, and what is your specific reason? Take a moment to think about it. Got your perfect Peel paragraph formulated? For validation, an expert student would choose gender, because you can apply a simple validation rule restricting input to just M or F, preventing sensible errors. For verification, the master student chooses the license field. Why? Because a license is a random string of alphanumeric characters like L4579. A computer cannot know if L4579 is sensible because there's no logical mathematical pattern to validate against. It must be visually verified against the physical paper license to ensure a typo wasn't made during data entry. If you can articulate that exact difference under pressure, you are operating at an incredibly high level.
Now we enter Act 5, the final and most complex stage of the masterclass, mastering SQL queries. This is literally the final boss of the database section. SQL questions often carry heavy marks, and if you don't know the exact syntax, you can waste 20 minutes trying to guess. A single missing quote mark means 0 marks. Let's rapidly break down the essential syntax demanded by the Cambridge syllabus. Think of this as your cheat sheet. Select tells the database exactly what fields or columns you want to show in your output. From dictates which specific table you are pulling the data from. Where is your condition or filter? It's how you isolate specific records. Sum is a mathematical function for adding up numeric values within a field. And order by is used for sorting the final results either in ascending or descending alphabetical or numerical order. If you deeply understand these 5 commands, you can decipher almost any IGCSE database query they throw at you.
Let's see how this built by looking at the actual populated table. We have our raw data. Mr. Yo teaches mathematics, Ms. Singh teaches science, Mr. Patel teaches geography, and so on. We need to query this data to extract meaningful information. A database is completely useless if we can't search it efficiently. Cambridge will give you a table just like this and ask you to predict the exact output of a specific SQL script. You have to stop thinking like a human and act exactly like the computer processing the code line by line without making any assumptions.
Here is an exact query pulled from the exam source. Select title, name, from teacher, where subject equals science. Let's trace it together. First, the from command tells us to look at the teacher table. Good. Then the where command applies a filter. We only want rows where the subject column exactly matches the word science. Scanning the table, that isolates Miss Singh and Mr. Ling. Finally, the select command tells us what to output. It only wants the title and the name. So the final flawless output you write on your exam paper is exactly this: Miss Singh and Mr. Ling. Nothing else. Do not write their class, do not write their gender. Precision is key. If you add extra columns, you lose the mark because you didn't follow the select command.
But Cambridge won't stop there. They will ask you to upgrade the query. They'll ask you to adapt and flow with changing requirements. If the question asks to show the results in alphabetical order, you append order by name ASC at the end of your script. If they want to include mathematics teachers as well, you upgrade the where clause to say where subject equals science or subject equals mathematics. This is where your entire strategy comes together. You know exactly what to filter and sort, your syntax is precise, and you apply the 3 rules that guarantee top marks: command word decoding, Peel framework application, and the time management matrix. Students who implement these computer science strategies see an average improvement of 2 grade boundaries. But only if they practice consistently with our weekly videos. Here's your final reminder: subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell.
Don't let another exam pass you by.
I am leaving you with one final, provocative challenge. Based on everything we've built today, what exact SQL statement would you write to display the names of all the teachers and their classes, sorted in ascending order by class? Think carefully about the select, the from, and the order by commands. Put it all together. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here.